The TandemHeart system is a percutaneous extracorporeal platform for temporary circulatory support that delivers up to 5 liters per minute of cardiac output augmentation with full pressure support for the heart. This unique platform is designed to meet 2 primary objectives for circulatory support. 1. Augment the flow of oxygenated blood to the patient's vital organs, and 2. Decompress the left ventricle to reduce the work of the native heart. Comparing the capability of different temporary circulatory support platforms requires the use of a consistent performance metric. One such metric, the pressure volume, or PV loop, provides a reliable framework to evaluate different approaches. During the cardiac cycle, measurements of pressure and volume inside the left ventricle are collected and then plotted against one another to form a loop. Since mechanical work is defined by the combination of pressure and volume, the area inside the resulting PV loop is equal to the work done by the heart in each cardiac cycle. By calculating this area, we can precisely measure the work being done by the heart, both before and after circulatory support is initiated. A smaller area inside the loop indicates less work being done by the left ventricle and more work being done by the circulatory support system. Now let's take a look at how the TandemHeart system works. The TandemHeart system withdraws oxygenated blood from the left atrium via a transeptal cannula and returns it to the femoral artery, creating an extracorporeal circuit that completely bypasses the left ventricle. The TandemHeart centrifugal pump provides up to 5 liters per minute of forward flow in a percutaneous configuration and has a relatively flat pressure profile, so it can deliver the desired flow and full pressure rise needed across a wide range of operating conditions. The combination of left atrial cannulation with a high-flow centrifugal pump enables the TandemHeart system to augment the flow of oxygenated blood throughout the body while decreasing the work demanded of the heart, represented by a reduction of PV loop area. Another platform for percutaneous circulatory support is the intraluminal axial pump, where the pumping mechanism is entirely contained within a small diameter catheter. Devices based on this platform are typically inserted through a femoral artery access site to withdraw blood from the left ventricle and return it to the ascending aorta. The small diameter axial pump has a sloped pressure profile, which means that the maximum flow rate is reached only when pressure in the LV is already high. As a result, the native heart must work to generate an initial rise in left ventricular pressure for the pump to achieve desired flows. This pressure profile also contributes to variations in flow throughout the cardiac cycle. During systole, about 1/3 of the cardiac cycle, pressure in the LV is high and flow through the pump reaches its theoretical maximum. However, during diastole, 2/3 of the cardiac cycle, pressure in the LV is low and pump flows are depressed. Finally, some blood volume must always be present in the left ventricle so that it may be sourced by the pumping mechanism. As a result, a lesser degree of decompression and likewise work reduction may be achieved. Another platform for percutaneous circulatory support utilizes peripheral cannulation of the femoral vein to source blood to an external pump and oxygenator before returning it to the femoral artery. Like the TandemHeart system, this platform uses a centrifugal pump capable of high flows with a flat pressure profile and can be initiated quickly. However, because blood volume is sourced from the central venous system away from the left side of the heart, percutaneous cardiopulmonary bypass does not decompress or remove blood volume from the left ventricle. As a result, while the organs are supplied with oxygenated blood, the work demanded of the heart may not be significantly reduced. No single system is the right choice for all patients, and each platform provides different benefits and consequences with varying degrees of circulatory support. With its capability to deliver 5 liters per minute of cardiac output augmentation and full pressure support, the TandemHeart platform can be a valuable tool in the mission to provide exceptional care to patients in need. When it comes down to performance, TandemHeart delivers. For more information, please visit cardiacassist.com.